Hello friends, today we'll do a numerical based on current mirror. Okay, here an example is given. Question is that the aspect ratio of the transistors in the circuit shown in figure are as follows. Find out current I1, I2, I3 and I4. So you have to find out current I1, I2, I3 and I4, and this is the circuit, and the transistors M0 to M4 is connected in this circuit. Their aspect ratio is given. M0 aspect ratio W by L is 10 by 1, M1 10 by 1, M2 10 by 1, M3 5 by 1, M4 15 by 1, and given threshold voltage of the transistors are same. Okay, now from our previous concept regarding the current mirror circuit, we can see that in this circuit M0 transistor M0, which gate terminal of the M0 transistor and the drain terminal is connected. This is a NMOS transistor. Gate, drain are connected. So as the gate drains are shorted, so M0 is working in saturation region. M0 is in saturation, and you can see that the gate terminal of M0 is connected to M1 transistor, also connected to M2 terminal, also connected to M3 terminal, also connected to M4 terminal. So also you can write the VGS of M1 M0 sorry M0 transistor equals to VGS of M1 transistor equals to VGS of M2 transistor equals to VGS of M3 transistor equals to VGS of M4 transistor. Okay, now from the current mirror circuit we have seen that if we take the ratio of the current of M0 and M1, then we can write for M0 current is I d0, that equals to I reference current, and reference current is given 10 milliampere. So this 10 milliampere equals to what? Mu Cox W by 2L into VGS minus VGS 0 minus VT 0 whole square, and also there 1 plus lambda VDS 0. Now we are neglecting here this term considering no channel length modulation effect. So we can write it mu Cox W by 2L VGS 0 minus VT 0 whole square. Now this is the current passing through the M0 transistor. So if I take the M0 and M1 transistor current ratio, so ID0 by ID1, that is equals to I reference by I1 equals to, we can write mu Cox W by 2L, W by 2L for 0, VGS 0 minus VT 0 whole square by mu Cox W by L for M1 transistor 1 by 2 into VGS 1 minus VT1 whole square. Okay, this we can write. So Mi1 equals to mu Cox into 1 by 2 into W by L for 1 VGS1 minus VT1 whole square. Now, as from here we can see VGS 0 equals to VGS1, so VGS 0 and VGS1 are same, and VT 0 and VT1 is same because the given the threshold voltage of the transistors are same. So these two will cancel out, mu cancel out, Cox cancel out, these two will cancel out. So from here we can see that I reference by I1 equals to W by L for transistor M0 by W by L for transistor M1. Now, from the information we have seen, the W by L of M0 is 10 by 1 and M1 is 10 by 1. So we can write 10 by 1 by 10 by 1 from here. Also we know I reference is given, that is your 10 milliampere by I1 equals to 1. So we can write I1 equals to 10 milliampere. So we have find out current I1. Now if we follow this rule for other transistors M2, M3 and M4, then we can write I reference by I2 equals to W by L 0 by W by L 2 equals to 10 by 1 by 10 by 1. So also we have find out I2 equals to 10 milliampere because I reference equals to 10 milliampere. So if we simplify this, then I reference equals to I2. Okay. Now same for the transistor M3. This is for M0 and M2 transistor. This is for M0 and M1 transistor. Now let's see M0 and M3 transistor. So I reference equals to, we can write W by L 0 by W by L 3 into I3. So I3 equals to W by L 3 by W by L 0 into I reference equals to W by L of M3 is 5 by 1 and W by L for M0 is 10 by 1. So we can write here 5 by 1 by 10 by 1. So we can write here this into reference is 10. So we can write from there I3 equals to 5 milliampere. So from M0 and M4 we can write I4 equals to W by L, 4 by W by L 0 into I reference equals to W by L of M4. M4 is 15 by 1. So 15 by 1 by 10 by 1 into 10. So the I4 equals to, you can write how much? It's 15 milliampere. So we have find out I1 equals to 10 milliampere, I2 equals to 10 milliampere, I3 equals to 5 milliampere, I4 equals to 15 milliampere.